Hello everybody. Welcome to this new chapter, Prognostics and Augmented Reality. In the what is meant by prognostics and what are and the future of vehicle diagnostics, we will see in this video. I'm sure many of you have heard the or hearing the word prognostics for the first time. We will discuss about it in this particular lesson. Now, when it comes to prognostics in automotive systems, prognostics refers to science of predicting future failure in vehicle components before they occur. It is more like predicting the failure. Unlike traditional diagnostics, which identifies the existing faults, prognostics uses the real-time data, machine learning, and historical trends to forecast issues, enabling predictive maintenance. Now, when it comes to key goals of prognostics, first is to prevent the breakdown by detecting early warning signs. Of course, this is the most important goal. And by preventing the breakdown earlier or before the breakdown, it reduces the repair costs. Optimize maintenance schedule. Enhance safety by uh, preventing critical failures. And when it comes to uh, uh, and when it comes to vehicle prognostic works, how does this work? First, it works with the help of data collection. And when it comes to modern vehicles, generate vast amounts of data from sensors, engine temperature, oil temperature, wheel speed, etc. And when it comes to ECU logs, fault codes, performance trends, and when it comes to telematics, GPS driving behavior, and cloud-based fleet management systems. All right. So these are the various types in which the data collection happens. All right. So let's see predictive analytics techniques. First is the machine learning. With the help of machine learning, AI models analyze the historical failure patterns and predicts battery failure based on voltage fluctuations. And when it comes to digital twin simulation, a virtual model of the vehicle mimics real world behavior and it simulates engine wear over 1 lakh miles. And coming to statistical reliability models, it uses variable analysis to predict component lifespans, estimates timing belt, failure probability at 90,000 miles, and anomaly detection. It flags deviation from normal operating parameters and detects unusual vibration in the wheel bearing before it fails. Okay, so these are some of the examples of the predictive analytical methods and also the methods through which this predictive analysis is happening. Now, when it comes to prognostic output, what is the output? The remaining useful life estimates brake pads have 3000 miles left and the failure probability analysis, example 60% chance of fuel pump failure in 30 days. And when it comes to maintenance alert, it replaces air filter in 5000 miles. All right. So these are the various kinds of the outputs of the prognostics. Now, what are the various applications of the prognostics? And when it comes to electric vehicles, battery health monitoring predicts cell degradation using charge and discharge cycles, prevents sudden range loss. Example, Tesla battery management system. And when it comes to motor and inverter prognostics, it detects the insulation wear in high voltage components. All right, and also it is used in electric vehicles, and within electric vehicles, it is used for turbocharger failure prediction and it predicts the turbocharger failure by analyzing the boost pressure and bearing wear. It also by keeping a constant vigilance on timing chain and belt wear, it monitors the stretch via the cam crank correlation. And when it comes to fleet management, predictive maintenance for trucks, the tracks oil quality, tire wear, and brake conditions. Okay, by constant monitoring of these things, it reduces the downtime. For example, UPS uses AI to optimize routes and maintenance. UPS is a major courier company in US and it is using AI to optimize routes and maintenance. Now, what is the future of vehicle diagnostic prognostics? Now, when it comes to first step in every way is artificial intelligence and machine learning dominance and self-learning algorithms. Cars will continuously improve failure predictions based on global fleet data. Next is edge computing. And when it comes to edge computing, onboard AI chips like NVIDIA drive process data without cloud dependency. Now, the biggest advantage of edge computing is it reduces the latency. All right. And when it comes to over the air diagnostics and repairs, the real time updates, the Tesla already pushes software fixes for issues like brake calibration, remote prognostics, and dealers receive alerts before the customer notices a problem. All right. Coming to the blockchain for secure diagnostics, first is the tamper-proof maintenance records and service history based on blockchain to prevent odometer fraud and smart contracts for repairs. All right. And when it comes to automatic warranty claims when a failure is predicted, so automatic warranty claims, it enhances the smart contracts for, it complements the smart contracts for repairs. And when it comes to augmented reality, it assists the repairs. Technicians use augmented reality glasses to view real-time diagnostic data overlaid on the engine and follow step-by-step repair guides. Okay, in the augmented reality, when they put on that augmented reality glasses, it step-by-step guides the technicians how to repair. Okay, one famous augmented reality kit is BMW's augmented reality toolkit. It also integrates with smart cities and V2X. And when it comes to vehicle to everything communication, cars share diagnostic data with the traffic lights, service centers, and other vehicles. For example, a car predicts brake failure and alerts nearby repair shops. Okay. Now, quantum computing in diagnostics, ultra fast failure simulation. And quantum computers could model millions of failure scenarios in seconds. Okay, so these are all the various features of vehicle diagnostics and prognostics. And one big advantage of this quantum computers is because it can predict millions of failure scenarios in seconds, the the downtime of the vehicle can be managed to be kept as low as possible. So what are the challenges and limitations? When it comes to challenges, first thing is data privacy concern. All right. So some fleet owners may or may not be comfortable sharing their vehicle data with everybody. So first of all, the question is who owns the vehicle data? And what is the potential solution? GDPR style regulations for automotive data. And when it comes to standardized issues, mixed protocols across the brands. And when it comes to potential solution, SAE ISO mandate for prognostic data formats. When it comes to false positives, what is the biggest challenge? It may be false positive. Sometimes the impact is unnecessary repairs due to incorrect predictions. Maybe the prognostic may sometimes become overcautious, so that may lead to unnecessary repairs even though repair is not necessary. And the potential solution is improved AI training with larger data sets. And when it comes to high implementation cost, it is expensive for older vehicles. All right. So aftermarket dongle is the potential solution. Now, let's see one small case study. Tesla's predictive maintenance. Tesla vehicles upload real-time data to the cloud, and AI detects anomalies. For example, battery cell imbalance. And example a Model 3 owner receives alert 12-volt battery replacement recommended in 14 days. And the mobile service schedules a replacement before failure. So as you can see, this automation has its own advantages, but it has a disadvantage also. Even though the owner receives an alert, owner may be slightly complacent. He may think that, okay, why not necessary in 14 days? We may do it in another 2 months. So it is like replacing the free will of the owner. And when it comes to the result, 50% fewer roadside assistance calls and extended component lifespans due to proactive care. Okay, so hope all of you got the various challenges, limitations, and the major ways in which this is aiding the onboard diagnostics. How this modern technology called prognostics in aiding the onboard diagnostics, this lesson clearly discussed. So in conclusion, by 2030, most vehicles will have AI-driven prognostics and self-repairing cars. Diagnostics will shift from fixing problems to preventing them early. All right. And when it comes to takeaways, key takeaways, prognostics is the next evolution of the vehicle diagnostics. And when it comes to AI, IoT, blockchain, will revolutionize the maintenance, and the future is predictive, connected, and autonomous. All right. Now this is more like a common knowledge. Thank you.